Hello everyone. In this video we are going to learn the various concept of hydrogen chloride gas and hydrochloric acid, but the first one is hydrogen chloride gas. That is what we are going to learn today. Now this gas, hydrogen chloride gas, actually it is a polar covalent compound. Now what do you mean by a polar covalent compound? It is a compound that is formed by the sharing of electrons. As in hydrogen, it has one electron in the outermost shell. In the same way, chlorine, it has 17 electrons. So it has 7 electrons in the outermost shell. See, 2, 8, 7 is the electronic configuration. Now what happens? Hydrogen and chlorine, they share 1 electron each, and thereby the compound hydrogen chloride is formed. So this is a covalent compound. The word polar means although the electrons are being shared, yet hydrogen and chlorine develop some charges. Why so? This is because of difference in attracting power of electrons. Chlorine has more power of attracting electrons, that is, it has higher electronegativity, and hydrogen is less. So H develops a slight positive charge and Cl develops a slight negative charge, and thereby it becomes a polar covalent compound. So hydrogen chloride is a compound which is formed by sharing, but as charges are developed, so it becomes a polar covalent compound. This gas dissolves in water to produce hydrochloric acid, which has a common name, muriatic acid, hydrogen chloride. Now how is hydrogen chloride gas produced? In some common ways. The first is direct combination. If we combine hydrogen and chlorine under diffuse sunlight, it will produce hydrogen chloride gas. Mind it, it should be diffuse sunlight and the hydrogen should be moist. Moisture acts as a catalyst here. If the experiment is performed in direct sunlight, explosion will occur. So it is strictly done in diffused sunlight. That is the first general way of preparing. The second is by the reaction of a metallic chloride with sulfuric acid, concentrate sulfuric acid. So metallic chloride being NaCl, sodium chloride or calcium, any chloride can be used along with concentrate sulfuric acid. The temperature should be less than 200, which we will discuss later on. It produces sodium bisulfate plus hydrogen chloride gas. This is a general way, and this is also the lab preparation of hydrogen chloride gas. See, NaCl plus H2SO4, temperature less than 200 gives NaHSO4 plus HCl. Now the temperature is more than 200, it will produce Na2SO4. This NaHSO4 is a acid salt, and this Na2SO4 is a normal salt. Acid means some part of acid, that is hydrogen, is left behind in the salt, and in Na2SO4 hydrogen is completely displaced, so it is a normal salt. How is the gas collected? It is collected by the upward displacement of air, because HCl is heavier than air. At the same time, it is highly soluble in water, so water cannot be used. Now when we are collecting HCl gas above air, then we have to be sure when the jar is filled with HCl gas. Now how will you check? To check whether the jar is filled with HCl gas, we dip a rod in ammonium solution. And what is ammonium solution? It is ammonium hydroxide solution. We dip a rod in it and we bring it near the mouth of the jar containing HCl gas. If white fumes are formed, then the jar is filled with HCl gas, and if you don't see any fumes, the jar is not filled with HCl gas. The white fumes is nothing but ammonium chloride. NH3 plus HCl, it will give ammonium chloride. NH3 is liberated from the ammonia solution. Now regarding lab preparation, we have to learn some important points. Points being, why is NaCl used? It is cheap and easily available, the first and foremost. Why is sulfuric acid used? This is because it is a non-volatile acid. Now volatile means which changes into vapor form very easily. Sulfuric acid is a non-volatile acid, hence it can easily displace HCl from NaCl, but it will not mix with the HCl gas. So sulfuric acid is preferred. Now if we use nitric acid in its place, nitric acid is a highly volatile acid. So it will volatile with HCl, it will get mixed with HCl and it will be difficult to remove or separate. So we cannot use nitric acid in this process. Now why is the temperature kept below 200, not above 200? There are a few points. Above 200 you have seen sodium sulfate is formed. Now this salt sticks to the glass and it becomes difficult to remove. So the temperature should be less than 200. Other important points being, some amount of fuel is wasted. The glass apparatus may crack at high temperature, so we prefer temperature less than 200. Now what is the drying agent used? HCl gas reacts with some of the drying agents. So the most preferred drying agent is sulfuric acid. It absorbs water vapor from it and dries it, whereas the other drying agents react with HCl gas. So the reaction, calcium oxide reacts, produces calcium chloride plus water. Phosphorus pentoxide, again a drying agent, reacts to form phosphorus oxychloride and metaphosphoric acid. So we cannot use these two drying agents. Now important point of HCl gas fumes in moisture. It means if it is released, you will be able to see white fumes in the air. Now what are these white fumes? HCl gas is highly soluble in water, I told you earlier. So the HCl gas dissolves in the water vapor and it gives it a misty appearance. So it appears as fumes in moisture. Now it is a highly soluble gas. Now how to prove that? So we had to perform a fountain experiment. See, there is a jar, it contains HCl gas. This is a round bottom flask. There is a container below which contains blue litmus solution. And there is a dropper. It contains some amount of water in it, and there is a jet where one end is in the blue litmus solution and the other is in the round bottom flask. Now what we have to do is press the dropper and put 2-3 drops of water in the flask. As the water enters the flask, HCl gas, being highly soluble, dissolves in water and thereby a partial vacuum is created. This partial vacuum lowers the pressure, hence the outside pressure being high, it presses the blue litmus solution which moves up the jet and comes out in the flask as a red fountain. Now why is it changed to red? This shows HCl is an acidic gas, and acidic gas will always change blue litmus solution to red. Hence the experiment proves two important points. First, HCl being highly soluble, and second, HCl is an acidic gas. See, that is the reason I have put in. The outside pressure pushes the blue litmus up the jet tube. When the solution emerges out, it changes to red, showing HCl is an acidic gas. Thus, it can be concluded that HCl gas is highly soluble and acidic in nature. Now, what is the effect of HCl gas on indicators? HCl changes. If it is blue litmus, it changes to red. Methyl orange changes to pink. Phenolphthalein is a colorless solution, it remains colorless. But if we add some alkali in it, alkali as in sodium hydroxide, potassium hydroxide, it changes to pink. Now alkaline phenolphthalein changes to colorless when HCl gases pass through it. Now what are the reactions that this gas follows? With ammonia gas, if you react HCl gas, it will produce dense white fumes of ammonium chloride. See, two gases reacting to form a solid. With active metals, now what do you mean by active metals? We have already learned there is a series of metals which is known as activity series. In this series, the metals which are placed above hydrogen are said to be active. These metals, when react with hydrogen chloride gas, it will produce hydrogen gas. So this was the brief concept of hydrogen chloride gas. In the next video, we'll learn about hydrochloric acid. Thank you.